This one is a question that engages trigonometric identities and also works with proving. Let's start with the part that wants us to prove. Now, check this. All right. We are required to prove the identity. We're required to prove the identity. It says here, prove the identity. Okay, prove the identity. One of the things that you guys are scared of, identity. All right. The identity says 1 over 1 minus sine of x minus 1 over 1 plus sine of x is as good as 2 tan of x divided by the cosine of x. All right. So what is the protocol or the process of proving these things? Always pick one side that you think you can simplify and try and make it look like the other side. So I think my left-hand side looks more juicy than the right-hand side. So I'm going to say, let's start with the left-hand side examiner. The left-hand side was given to us as 1 over 1 minus the sine of x minus 1 over 1 plus the sine of x, right? Now, what did I say earlier? I said to people before we got to what we are working on now, that when you are dealing with these kinds of problems, they are beyond trigonometry, right? A lot of algebra is involved in these particular questions. For example, when I look at this question that we are sitting with here, I don't see trig first. The first thing I see here is I see a skill that comes from algebra that needs to be engaged. What skill is that? The skill of adding fractions, right? This is not about trig yet. It's about fractions, right? Very important. So I ask myself a simple question. When I have something over something minus something over something else, how do I add those two fractions together, right? I always say draw the division line, keep the denominators as the denominators. So B and D, I'm going to keep them. Keep the denos the way they are. Keep them there. Right after, then cross multiply this guy with that guy and the other one with the other one. Everything will always work out beautifully for you. You will never have problems. So this is me. I'm now going to draw the division line. So I'm going to keep my denominators. This guy here is my first denominator. The second one is also my second denominator. So I've got 1 minus the sine of x in the first bracket, and I've got 1 plus the sine of x in the second bracket, right? Those are the denominators, remaining denominators. And then after that, you start with cross multiplication. Start from the top, right? This guy multiplied by the bracket. So 1 multiplied by anything will remain the same. So 1 times that bracket will just be 1 plus the sine of x. And when I'm done with that, I'm now going to do this one. This is -1, right? Please pay attention to the fact that the minus sign belongs to that one you see on top there. So this is -1 times the second bracket. It simply means those terms inside the bracket will just change signs. 1 will now become -1, and negative times negative will become positive. So you're going to have positive sine of x, right? Okay, cool. So let's see what we can do cleaning this up. On the numerator, 1 will subtract 1 out. Sine and sine will give us 2 sine x when you add them. On the denominator, again, if your algebraic skills are up to scratch, you should notice that you're dealing with the difference of 2 squares. 1 minus sine, 1 plus sine, which will become the first thing squared minus the second thing squared. But if you don't want to do that, you can do all the forwarding business of 1 times 1, 1 times sine, this and this and this and that. You will eventually end up with 1 minus sine squared x. But if your algebra is up to scratch, you will notice that you're actually multiplying 2 brackets that will lead you to the difference of 2 squares. Okay, cool. And then if I work on this, what do I end up with? I end up on the numerator with 2 sine of x. On the denominator, now this is where I'm going to engage my squares identity. You guys should know on the denominator that if I've got the sine squared of x and I add it with the cos squared of x, it should always give me an answer of 1, right? So if I take this part here to that side, or I subtract sine squared x on both sides, I'm going to end up with cos squared is 1 minus sine squared. If you do witchcraft math and things jump the equality sign and they change from being positive to being negative. So the denominator is just as good as cos squared x, right? And now here's where it becomes exciting. The cos that you see there, right? The cos that you see here, I can basically divide by cos on both sides. So I've got 2, right, times the sine of x divided by cos squared, which is what? Which is, check this out, it's actually cos of x times cos of x. I just expanded my cos squared because I want you to see it without any fighting happening. So this part here, this sine x divided by cos x, is just going to be tan on the numerator. So I'm going to have 2. Then I'm going to have tan of x divided On the denominator, I still have got the other cos of x remaining. And what is this? Well, voila. The left-hand side is indeed equal to the right-hand side, because this is exactly what the examiner wanted us to prove. If you check the opening statement that we're dealing with here, we're required to prove that what you have on the left is as good as 2 times x divided by the cosine of x. Beautiful question indeed. Very exciting. I hope it has actually helped you to understand what you need to work with. Okay, cool. Right. The next question here is the one that involves compound angles. And this is a beautiful one. Compound and double angles. Check this out. It actually says the following. We are told that if the sine of 28 degrees is as good as A, and the cosine of 32 degrees is as good as B, right? We need to find the following in terms of A and B. Find in terms of A and B. Let me write it here because I'll use that to, okay, find in terms of A and B. A and B, a couple of things, right? Number one, we need to find what is cos 28 degrees. Number two, we need to find what is cos 64 degrees. And number three, we need to find my favorite, sine of 4 degrees. So these are the three things that we need to find the solutions to if sine of 28 is A and the cosine of 32 is equal to B. Right. Now, what is your method when you're dealing with these kinds of questions? What is that one thing that must come to your mind when you have this kind of a setup, right? Always chase the number, right? Chase the numbers that were given to you. Sine 28, so I'm interested in the number 28. I must get 28 at all costs. 32, so I'm looking for 28 and I'm looking for 32. Those two numbers must play a role. If I don't see them, I can't write A or B. The only time you can write A is if you have sine 28. And the only time you can write B is if you have cos of 32. So when I'm given any number, my goal is one. Can I rewrite it in terms of 28 or 32 or both of them? One way or the other, those numbers must play a role. Right. So let's see the first question. The first question is pretty straightforward. It's not complicated if you're asking about it. Why? Because already it is in terms of 28 degrees. So what I'm going to do is I'm going to take this sine of 28 degrees and draw a right-angled triangle for sine 28 degrees, which should lie in the first quadrant of your Cartesian plane. So this is how it is simply going to look. I'm going to have a diagram that happens to be a right-angled triangle. I'm going to put in 28 degrees here, right? And you guys should know, according to our knowledge, the sine of any angle is given by the opposite divided by the hypotenuse. Now, if you say sine 28 is A, I can rewrite that as A divided by 1 because I'm chasing opposite and hypotenuse. So my opposite side is going to be A and my hypotenuse is going to be 1 because sine of 28 is going to be A divided by 1, which leads us to the A that you guys are looking at. Now, if you look there on the x-axis, we are missing the length of that particular triangle. And if you apply the theorem of Pythagoras, Pythagoras said x squared plus y squared is equal to r squared according to this right-angle triangle. And if you simplify by substituting your y as a, you're looking for x. So x squared is going to be 1 squared minus our y, which is a squared, which means on this side, we're dealing with 1 minus a squared. That's actually what your x is going to eventually become, right? 1 minus a squared. So if you're asking me for cos of 28, it's pretty straightforward. I won't even think about it because I'm just going to go and say by definition, the cosine of 28 degrees is always given by the adjacent side divided by the hypotenuse. This comes from SOHCAHTOA, which is the original definition that we're using when we are introducing these trig ratios. So the adjacent side is the square root of 1 minus a squared divided by the hypotenuse, which is 1, and eventually you end up with an answer of 1 minus a squared as your cosine of 28 degrees. Right. The next question is the cosine of 64. Cosine of 64. Now, if you go back to the given information, 64, what is the relationship between 28 and 64 or 32 and 64? Somebody has just said it. 64 is just double of 32, right? So I'm going to go back and rewrite cos 64. What am I going to say? I'm going to say, okay, when we're solving number 2, we're going to say the cosine of 64 degrees is just the cosine of double 32 degrees. So this is going to be where we're going to use the 32 degrees given information to try and expand this. Now, a double angle, of course, can be expressed in three different forms. You can write it in terms of cos, you can write it in terms of sine, or even in terms of both cos and sine. So which one is ideal in this case? Which one is the best to choose? Let's go and look at what was given to us. Now, in the context of 32, as far as 32 is concerned, you'll agree with me that we were given cos of 32 as b. So it's wiser to express it in terms of cos only, because then we'll have 32 and we'll be able to find the solution without any complications. So in terms of 32, in terms of cos, my cos double angle of 32 is just going to be 2 cos squared, that number 32 minus 1, right? This is the expansion of a double angle of cosine, right? 2 is a number, I'm going to write that. Cos 32 is apparently b, there's a square, I'm writing that, and then there's a minus 1. So that will be the solution to the cosine of 64, expressed in terms of cos, because the given information was about cos, right? Okay, our last question for today is where we are asking you to work out the sine of 4 degrees. So I'm going to be a little bit quick on this one because we ran out of time. So we're looking for the sine of 4 degrees. Now, 4 degrees, like I said, think about it. How can I use 32 and 32 and 28 to express that 4? So if you say 32 minus 28, you end up with exactly the number you are interested in. Remember, you can't use A and B if you don't see 32 or 28 anywhere in your question. So 32 minus 28 gives us what you're looking for. So I'm going to write this as the sine of 32 degrees minus 28 degrees, right? And now, I'm now dealing with what we call compound angles, right? The expansion of sine something minus something else always amounts to the sine of the first angle, the cosine of the second angle. If it's a minus, you keep it the way it is, times the cosine of the first angle times the sine of 28 degrees, right? Okay, and then after what we have, we just did an expansion of sine something minus something else, which is available in your information sheet. You shouldn't actually struggle to know that the sine of 32 minus 28 is sine 32 cos 28 minus cos 32 sine 28. Now let's check what is going on here. I'm looking for sine 32, right? Do I have sine 32 from the given information? No, we don't. So I'm going to take the diagram of cos 32 and manipulate it to assist me, like we did when we were looking for the first part, right? When we were looking for the solution of the first item, and allow me to put it here, right? What do we know? Well, we know that we can draw a right angle triangle in the first quadrant. For which angle? For exactly 32 degrees, right? But we were told, remember we were told that the cosine of 32 degrees is b, which we can write as b over 1. So cos is adjacent over hypotenuse. If you apply Pythagoras, the y is going to be the square root of 1 minus b squared. I trust your skills of applying the theorem of Pythagoras. Now you're asking me for the sine of 32. Sine of 32, I'm going to read it from the diagram of 32. So it's going to be the opposite sine divided by the hypotenuse, which will leave us with the square root of 1 minus b squared divided by 1, which is exactly what you have now. And then the cosine of 28 degrees, cos of 28. Did we find the cos of 28? Yes, we did. We got the square root of 1 minus a squared, right? So this is going to be the square root of 1 minus a squared. And then minus the cos of 32. This one is a joke. It is b. It was given to us. And the sine of 28 was given to us as a. So basically, this, beautiful people, should be the solution. Of course, if you wanted to multiply the brackets to remove them, you could have done exactly that. But I think even if I left it here, there wouldn't be a problem because you guys are very good at simplifying brackets by multiplications.